This lesson's about keeping safe on the road, and it's how to approach those higher math problems. So by the end of this lesson you should be able to calculate the force exerted by large decelerations. So in the last lesson we looked at the dangers that are caused by these large decelerations, and that included things like the brakes overheating, losing control of your steering, and the increase of the impact force. And of course if there's an increase in impact force, then that's going to increase your risk of injury. But for the higher paper you may have to calculate these large braking forces. And so here's a typical exam question. You're given lots of information, and in order to approach this question you're going to need to use two equations. And the first equation you need to use is one that we saw back in forces unit, where we looked at calculating motion, and that's v squared equals u squared plus 2as. So remember, that stands for v squared is the final velocity squared equals the initial velocity squared plus 2 times acceleration times displacement. And remember, displacement is just the vector quantity of distance. You're then going to need to use force equals mass times acceleration. So you use the first equation in order to calculate the acceleration, which you can then input to the force equals mass times acceleration in order to work out the braking forces. So pause the video now, have a go at this question, and then I'll come back and show you how to work the answer. Okay, so the first thing to do is to write down the information that you've been given. So we were given mass as 40,000 kilograms. We were given the initial velocity, so that was 25 meters per second. We were given the displacement, or the distance, of 100 meters, and we were also given the final velocity. So the final velocity is 0 because the lorry is coming to a stop. So we're then going to use the equation v squared equals u squared plus 2as. Now we need to rearrange that equation in order to give us acceleration on its own. So the first thing we're going to do this in step by step. The first thing we need to do is get rid of the whole of this 2as from this side. So we're going to go v squared, take away 2as, because if we take away 2as here, it takes it away from this side. It gives us the initial velocity squared. So now what we need to do is we need to find a on its own. We can disregard v squared because we know that to be 0. So we've got minus 2as equals u squared. So to get a on its own on this side, we would need to divide this side by 2s. And so we do that to the other side. Minus, so divided by 2s. Now if we plug the numbers into that, what we're going to get is u squared, so 25 squared divided by 2 times 100, which gives us 625 divided by 200, which equals an acceleration of 3.125 meters per second squared. So we now have the acceleration. So what we're going to use now is we're going to use force equals mass times acceleration. So our second equation, force equals mass times acceleration, we were given the mass as 40,000. We're going to times that by the acceleration of 3.125, which gives us an overall force of 125,000 newtons, or 125 kilonewtons, 125 kilonewtons. And so that's how you go about that problem. So as we say, practice makes perfect. Pause the video here now and have a little go at these two problems. For some reason they're both numbered 1, but question 1 and 2. Have a go at these two questions. So hopefully you realise that on the first question that was just a carbon copy of what we've just done. And so the first part of that question was to use the v squared equals u squared plus 2as in order to calculate acceleration. Then take that acceleration and add it into the force equals mass times acceleration equation, and you should have come up with an answer of 4,032 newtons. Second one was a little bit different, and this was in reverse. So the first thing you needed to do was to use the force equation in order to calculate acceleration. You then went on to use the v squared equation in order to work out the stopping distance, and again there you just needed to rearrange in the same way that we did for acceleration, to rearrange that equation to give you the distance, and you should have come up with an answer of 45 metres. So hopefully you now have an idea as to how to answer those higher math problems if they ask you to calculate large deceleration.